All right, so this section is on exponential functions, and we'll just kind of get into the basics here. We're going to get too in the weeds. Just kind of introduce this, look at basic graphs, things like that. So an exponential function is just a function of this form where basically the x is in the exponent. That's the part that makes it an exponential function. A here is called the base. And A is between, or I should say A is greater than 0 and A is not equal to 1. And the reason A cannot equal 1, if A was 1, you'd have 1 to the x, which equals 1 no matter what x is. So there would just be a constant function. The domain of these, and we'll see this when we look at the graph, the domain of all exponential functions is all real numbers. And then the range, at least for now, is 0 to infinity, not including zeros. So there's no way to solve this equation, 0 equals a to the x. There's no way to do that. If a is greater than 1, then this is an increasing function. If a is between 0 and 1, that will be a decreasing function. And let's see exactly what that looks like. So when a is greater than 1, so say we have 2 to the x or 3 to the x or 4 to the x, we have something that looks about like that. So it's going up like that, it's going like this. And so this part going in this direction, this graph will never touch the x-axis. It's going to get closer and closer, but it's never actually going to touch it. So that we call that an asymptote, which we haven't talked about asymptotes, I don't think. Maybe we did earlier, but in any case, it's never going to touch that. So that's why the range starts at 0, but it doesn't include 0, and then goes up to infinity in that direction. The y-intercept with just the basic exponential function is going to be 1, because when x is 0, of course, a to the 0 is going to be 1. And if a is less than 1, or between 0 and 1, then it is just going to look like this. And same thing, going in this direction, the graph will get closer and closer to 0. It will not touch 0. And then same y-intercept is going to be 1. So we're basically just reflecting it around the y-axis. And we can talk about why that is related to the transformations. If you remember how we reflect around the y-axis, that is putting a negative x in for x, so f of negative x. And if you recall, we'll talk about this at some point. If a is between 0 and 1, so say 1/2, that's the same as 2 to the negative x. So it's kind of like we're putting a negative x in if we have a greater than 1. So say y equals 2 to the x, or y equals 1/2 to the x. This could also be written as 2 to the negative x. And so we're basically putting a negative x in for the x. And so these two graphs would be reflected around the y-axis for the same reason that we saw in an earlier section. So let's see if we can sketch a couple of these. So we have 3 times 2 to the x, and we have 1/2 to the x plus 3. So let's look at this one. You can use the same transformation rules that we've seen apply to these exponential functions. So this 3 in front, if you remember from the transformation section, multiplying the function by a constant, which is what this is doing, will vertically stretch the graph. And so what happens is it gets taller faster, we'll say. So it's going to go up faster. The y intercept, so you plug in 0 for x, that would be 1. So we have 3 times 1. Now that is going to be 3 and not 1. The domain is still all real numbers. And the range is still 0 to infinity. So we have not changed that. We haven't shifted this at all. All we've done is stretched it up, but it still covers the same domain and range. For 1/2 to the x plus 3, we have, now what does the +3 do? That shifts it up. And so instead of this invisible fence called the asymptote at 0, we're going to shift that up to 3. And so now it is going to look like that. Actually, that is not right, because we have 1/2 is between 0 and 1. So it is going to look like this. Now, so that dotted line is 3. It's going to approach that. And what's the y-intercept? So if we plug in 0, 1/2 to the 0 would be 1. 1 plus 3 would be 4. So the y-intercept is at 4. All right, now what's the domain and range? The domain, again, of all exponential functions, this is not going to change, is -infinity to infinity. Now, once you get to more advanced math classes, if you talk about some exponential functions, you could put something up here that would make the domain not all real numbers. But for us, we're just kind of putting basic. We're just probably just always have an x up there. So the domain is going to be all real numbers. And then the range is not 0 to infinity because we've shifted this up. So the range is now 3 to infinity because of the vertical shift. All right. So those are the basic graphs. And so let's talk a little bit about law of exponents. You will have a couple of problems in the homework regarding these. Nothing too complex, nothing that you would not have seen before in algebra or pre-calculus. But just review these. If you're multiplying, the exponents will add. If you're dividing, the exponents will subtract. If you have an exponent raised to an exponent, you're multiplying. And then as long as you're multiplying in parentheses, the exponents will distribute. So pretty basic laws of exponents that you would have seen before. So the next example, if the function could be linear or exponential, write a possible equation for the function. So now how do you decide this? Linear functions, the numbers in the y column will have an additive difference. So linear is adding, exponential is multiplying. So the way you decide this is look in the y column. As long as the x's are uniformly going up, in other words, we don't have 0, 1, 3, 8, 9, 12, something like, kind of randomly going up. There's a definite pattern to this. If the pattern here is additive, meaning we're adding the same thing to each new y value, then it's going to be linear. If we're multiplying or dividing, then it's going to be exponential. So you see this one, we're going up by 5s every time. And so all that tells us is, well, first of all, it's linear because we're adding. But then if we want to find our slope and our y-intercept, the y-intercept is going to be 5 because that's what the value of x, or the value of y when x is 0. And then the slope is also 5 because that's how much we're going up. So the difference between the terms is going to be the slope. And then the value when x is 0, that's going to be the y-intercept. So this is just y equals 5x plus 5. This one, and I guess we could write division because that's what this one is doing, multiplication or division. So in this case, you see 18. Obviously, the difference is getting smaller as we go. So it's not a constant additive or subtraction. 18 divided by 3 is 6. 6 divided by 3 is 2. 2 divided by 3 is 2/3. 2/3 divided by 3 is 2/9. So these are dividing by 3. And what that tells us, so we're looking for y equals c times a to the x. So a is our base, c is going to be our y-intercept, because if x is 0, that's going to be 1, and then the y-intercept will be c. So this one, well, so let's figure out what the y-intercept is. If we're dividing by 3 going this way, we must be multiplying by 3 going up. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3, that would give us the value when n is 0. And I guess we should write this as p into n. So 18 times 3, what is that? 54. And then the a is just going to be, what are you multiplying or dividing by? So we're dividing by 3, so let's put this as 1/3. All right, so fairly easy as long as you can kind of know the rules here. Of course, you can with the linear. We have 2 points. We can always get the linear function from 2 points, but we can do that. We can do it easier than that. Same thing with the exponentials. You can plug in 2 of these points, and you have 2 equations that you can get the c and you can get the a from. And in fact, I think we're going to do that on this next example. And I put X there. That should be in. So of course you got to pay attention when you're doing this homework. Make sure you use the right variables. So the next one. So now we have a graph, and we're given 2 points, and we need to figure out what the equation is. So we're going to essentially write 2 equations, and there may be ways, multiple ways to solve these. So we'll kind of see what we get. So just plug in the 2 points for X and Y. So 6 equals CA to the first, and then 24 equals CA cubed. And I guess there may be several different ways to do this. One way that kind of stands out to me is you can rewrite this one as CA times A squared. And we know that CA equals 6. So let's write this as 24 equals 6A squared. And then we can solve for A. So we get 4 equals A squared. We take the square root, and A could be plus or minus 2, but we know that A has to be positive. So A cannot be -2. So A has to be positive 2. And then we will plug A in here, solve for C, and we get C is 3. All right, so that means our equation is 3, y equals 3 times 2 to the x. Okay, so any type of equation, any type of graph that you need to get the equation, as long as you know 2 points, that's going to be the basic way to do it. Set up 2 equations. Probably what you've seen in the past is doing this with linear equations, but the same idea applies. Set up 2 equations, and we're going to eliminate one of the variables somehow, and solve for the remaining variable, and then plug that back into the other equation and solve for the second variable. So in this case, we kind of break this one down again. A cubed, we can write as A times A squared, and then this is exactly what we have over here. So so once you practice that, I think once you see it a couple of times, that should not be too difficult to do. But as always, if you have questions, you can email me and we'll answer those.